Okay, now let's talk about integration of Trigo functions. Okay, so recall we have differentiated Trigo functions before, right? Okay, so integration is basically the reverse of differentiation. So when we talk about differentiating, okay, recall when we are going to differentiate, say, sine function. Okay, so when we differentiate sine, we will get cosine x. Okay, so it means the reverse is also true. So therefore, when we integrate cosine x with respect to x, we will actually get back sine x plus c. Okay, so regardless that it will always be a plus c here for integration. Okay, when it's indefinite integral. Okay, later on you will learn about definite integral where you can know what is this plus c over here. Okay, then when we talk about differentiating cosine x. Okay, so when we differentiate cosine x, we will actually get negative sine x, right? Okay, so therefore, when we actually integrate, okay, when we integrate negative sine x with respect to x, we will actually get back our cosine x. Okay, but when we actually integrate sine x, right, we can take out this negative sign over here, correct? Okay, so that's why when we integrate sine x, okay, I can divide both sides by -1. So I will actually get negative cosine x plus c. Okay, so that's how we get the results here and here. Okay, so that's why when we integrate cosine x, we'll get positive sine x plus c. When we integrate sine x, we'll get negative cosine x plus. Okay, so it comes from the reverse of differentiation. Okay, then also recall when we differentiate tangent x, okay, we will get secant square x. Okay, so the reverse will be true. So when I integrate secant square x, okay, secant square x with respect to x, I will get back my tangent x plus c. Okay, which is this part over here. Okay, so recall. Okay, so recall when I differentiate tangent x, then I will get secant square x. So the reverse is true, right? So how about integration of tangent x or tangent square x? Okay, we cannot use any of the reverse of differentiation for this. Okay, so there's no so-called rules for integrating of tangent x. Okay, and tangent square x, but it is not impossible to integrate tangent square x or even your sine square and cosine square x because we can use identities, okay, our Trigo identities to help us integrate these functions. Okay, so therefore it is not impossible to integrate. We can, but we will need to use Trigo identities. Okay, and I will later on emphasize why we need to use Trigo identities here. I know some of the questions that you guys might have, right, is why we cannot use reverse chain rule here, right? Okay, so reverse chain rule, as mentioned before, when we talk about polynomials, integration of polynomials, reverse chain rule is only possible for integration of polynomials. Okay, it doesn't work for Trigo. Okay, so remember this. Okay, so we have all of this basics down. Okay, now how about if now our angle is not just x? Okay, so my angle is now ax plus b. Okay, so one thing to take note of is when you differentiate or even when you integrate, right, the angle will always stay the same. Okay, so don't ever change the angle here. Okay, the angle will always be the same after integration. Same thing for differentiation. Okay, when you do differentiation, you also don't change the angle, right? Okay, so when I integrate sine ax plus b, okay, I will get cosine ax plus b first, okay, negative cosine ax plus b, but I also need to divide by the differentiated of the angle. Okay, so recall, right? Okay, recall when I differentiate instead. So when I differentiate, say for example, sine ax plus b. Okay, so when I differentiate this, I will get a times of cosine ax plus b, right? Okay, so where I multiply by the differentiator of the angle. Okay, so the reverse is true for integration. I will divide by the differentiator of the angle. Okay, so same thing for when I differentiate cosine ax plus b, I actually get a, okay, negative a times of sine ax plus b. Okay, so the reverse is true. So when I integrate sine ax plus b, I will get negative cosine ax plus b first, and then I need to divide by the differentiated of ax plus b, which is just a. Okay, then lastly, don't forget to add in a plus c here. Okay, same thing when I integrate cosine ax plus b, I will actually get sine ax plus b first, and then I need to divide by the differentiated of ax plus b, which is a. Okay, then again add a plus here. Okay, then when I integrate secant square ax plus b, I will get tangent ax plus b first, then divide by the differentiated of ax plus b, which is a. Okay, then again plus c here as well. Okay. Okay, so now that we have gone through the basics over here, right? Okay, of all our Trigo functions. Okay, now let's do a few examples together. Okay, when I want to integrate 3 sine x with respect to x. Okay, so I will write down integration of 3 sine x with respect to x. Okay, so first of all, for integration, we can always take out the constants here, right? Okay, so I will take it out. So it becomes 3 times of integration of sine x. Okay, so when I integrate sine x, I will get negative cosine x. Okay, so therefore it means I will have negative 3 cosine x plus c. Okay, so far still simple stuff. Okay, now when I integrate 3 over to secant square 2x, okay, with respect to x. Okay, what do I get? First step, always take out the constant here. Okay, so 3 over 2 secant square 2x. Okay, notice here my angle is 2x. Okay, so when I integrate secant square, I will always get tangent, right? So over here, I will get 3 over 2 first, then times tangent. Okay, the angle, remember, the angle will never change. So the angle is still 2x. Okay, then recall we also need to divide by the differentiated of the angle here, right, which is 2. Okay, then plus c. Okay, so when I simplify this, I get 3/4 tangent 2x plus c. Okay. Okay. Now, just now recall, right, we have talked about integration, okay, briefly on integration of sine square, cosine square, and tangent square, right? Remember I say we cannot use the reverse chain rule. Okay, so let's take a look at examples like this. Okay, so first of all, when I want to, okay, when integrating sine square, cosine square, and tangent square. Okay, here your reverse chain rule or your so-called power rule, right, don't work for Trigo. Okay, so do not work for Trigo. Okay, write this down. Okay, so your reverse chain rule only applies for your polynomial functions, okay, your normal algebra functions. Okay, so it doesn't work for Trigo. Okay, so yeah, let's say when I deal with sine square and cosine square, right? Then how am I supposed to integrate sine square, cosine square, and tangent square? So when I do that, I need to split them up into different functions, right? Okay. So in that case, I need to make use of trigo identities over here. Okay, that involves my sine square, cosine square functions. Okay. So when I make use of trigo identities, the identities that I will need are the double angle formula. Okay, so recall your double angle formula for your cosine and sine. Okay, so which part of my double angle formula will have this cosine square or sine square in them? It will be this two. Right. Okay, so I have a cosine square A here and a sine square A here. Okay, so when I want to integrate this, I can do some manipulation, right? So therefore, when I integrate, okay, say cosine square x, okay, then I will make use of the first one over here. Okay, so the first one over here means I can actually just integrate 1 minus cosine 2x over 2. Oh, sorry, cosine 2x plus 1. Okay, cosine 2x plus 1 over 2. Okay, so it means when I want to integrate cosine square x, it is the same as integrating cosine 2x plus 1 over 2. Okay? Okay, so essentially I can just break it down. So I am just integrating this cosine 2x plus 1. Okay, so now I've broken it down into two terms. Okay, so I can just integrate this directly. Okay, so there's no such thing as integrating cosine square and sine square by reverse chain rule. Okay, so when I integrate sine square, okay, I will have 1 minus cosine 2x over 2 dx. Okay, so this comes from this double angle formula. Okay, which means I am just integrating this. Okay, so that's how I'm going to approach my cosine square and sine square kind of integration. Okay, similarly, if I want to integrate tangent square, okay, recall I can integrate secant square, right, but not tangent square directly. Yeah. Okay, so when I want to integrate tangent square directly, I need to make use of trigo identity that matches tangent square and secant square together. Okay, so that I can manipulate my tangent square to be a function of secant square instead. Okay, so using this one, I will then have integration of tangent square x. Okay, I'm going to rewrite this as actually secant square x minus 1. Okay. Okay, so the common misconception is okay, let's write this down again. Do not apply reverse chain rule to Trigo for integration. Okay, write this down again to remind yourself there is no such thing as chain rule or power rule here. Okay, so it means you cannot do this. Okay, this one is a wrong way to do. Okay, so it means you cannot treat this as sine x whole thing square, okay? And then do your so-called reverse chain rule. Okay, so this is not equals to sine cube x over 3. Then you take the differentiated of your sine. No such thing. Okay, so this part over here when I'm writing down, right, is not true. Okay, so this one is not correct. Okay, so whenever you see a power like this, right, don't use reverse chain rule for Trigo. Okay, always change it based on their identity here that I've talked about. Okay, so now after talking so much on this, right, okay, now let's do a few examples. Okay, so when I have tangent square, okay, integrating of tangent square, remember always use secant square minus 1. Okay, so I'm going to change this to secant square to x minus 1. Okay, so when I differentiate secant square, I will get tangent. Okay, then the 2x remains, the angle don't change. Okay, then remember I also need to differentiate by the angle. Okay, so the differentiator of the angle is 2. So divide by 2. Okay, then minus x plus. Okay, then for integration of sine square x. Okay, so I need to make use of my identity. Okay, so this is integration of 1 minus cosine 2x over 2. Okay, so I can take out the half here. So it becomes just 1 minus cosine 2x, cosine x, 2x dx. Okay, then I will differentiate what is here. Okay, so when I integrate what is here. Okay, so when I integrate 1, I will get x. When I integrate cosine 2x, I will get sine 2x. Okay, then I need to divide by differentiated of 2x, which is okay, then plus. Okay, so when I simplify this, I will get half x minus 1/4 sine 2x plus c. Okay, so remember, don't ever change the angle. Okay, then here, when I integrate cosine square 2x. Okay, so same thing when you see powers in Trigo, right? Okay, make sure you change it based on their identity, because I cannot use so-called power rule or reverse chain rule, okay, in Trigo. Okay, so this, I need to change it into integration of cosine 4x plus 1 over 2 dx. Okay, why do I need to do that, right? Okay, because based on my double angle formula, cosine 2x is actually 2 cosine square x minus 1, right? Okay, so if I change the double angle to 4x instead, okay, then the angle here will also change. Okay, so it becomes 2 cosine square 2x minus 1. Okay, so that's why I replace this as cosine 4x plus 1 divided by 2. Okay, so therefore I will get, okay, I will take out the half first. Then I will get cosine 4x plus 1 dx. Okay, so putting the half outside, when I integrate cosine 4x, okay, I will get sine 4x divided by the differentiator of the angle. Okay, then plus x, then plus also. Okay, so then when I simplify, I will get 1 over 8 sine 4x plus half x plus c. Okay, then over here, right, you can either leave it in this form, or I can also change this sine 4x into the double angle formula for sine. Okay, so recall your double angle formula for sine is sine 2a equals to 2 sine a cosine a, right? Okay, so sine 2x equals to 2 sine x cosine x. So when I have sine 4x, this is basically 2 sine 2x sine 2x. Okay, so see here. Okay, so it means I can actually replace this as 1 over 8 2 sine 2x cosine 2x plus half x plus c. Okay, which is essentially just 1/4 sine 2x cosine 2x plus half x plus c. Okay, so you can also simplify to this, or you can leave your answer as this as well. Okay, okay, now let's look at one last example. Okay, so recall integration, there's no such thing as product rule also. Okay, so you cannot treat this as this times this, so I use product rule. Okay, so again, write this down. Oh, product rule in integration. Okay, not just product rule, there is also no quotient rule. Okay. Okay, so take note, this doesn't just apply to Trigo. Even your polynomial function also, there is no such thing as product or quotient rule in integration. Okay, so always remember this. This only applies for differentiation, not integration. Okay, so whenever you see, okay, remember in polynomials we have emphasized also, right? Whenever you see multiplication of terms, right, always expand it out into individual terms before you integrate. Or if you see quotient, okay, meaning your so-called division, right, you also need to split them out into their individual terms before you can integrate. Okay, so for Trigo, over here, when I see sine multiplied to cosine with the same angle here. Okay, so what kind of identity will give you sine multiplied to cosine? Okay, you will actually make use of this identity over here. Okay, where your sine is multiplied to cosine. Okay, so using the double angle formula, okay, so I have sine 2x equals to 2 sine x cosine x, right? Okay, so deriving it from this double angle formula, so if I have, okay, so it means if I have sine x cosine x, this will be equals to sine 2x divided by 2. Okay, similarly, it means if I have sine 3x cosine 3x, okay, it's double angle, right? So this becomes sine 6x over. Okay, so ultimately it means I can replace my sine 3x cosine 3x, okay, this so-called product, right, as sine 6x over 2. Okay, so I will integrate sine 6x over 2. Okay, then I will take out the half. So it means I am integrating sine 6x. Okay, so when I integrate sine, I get negative cosine, right? Okay, so I will have half times of negative cosine 6x. Okay, the angle doesn't change. Divide by the differentiator of the angle. Okay, then plus. So therefore, I will have negative 1 over 12 cosine 6x plus. Okay, so that is what I want to emphasize for all your Trigo stuff. Okay, so just take note, there's no such thing as reverse chain rule for Trigo. So you need to make use of your double angle formula, okay? Your identities there to manipulate such that you get single Trigo functions with no squares in them or any powers in them. Okay, for your cosine and sine. Okay, then you can integrate secant square, but you can never integrate tangent square directly. Okay, so it means I need to change my tangent square into a function of secant square using the identity. Okay, and same thing. There's no product rule, no quotient rule in integration. No matter you are integrating polynomials, trigo, exponential, or whatever. Okay, so no product rule, no quotient rule in integration. Make sure you get individual terms before you integrate. Okay. Okay, so that is for integration of trigo.